Very happy to have you all here. And
Good morning.
today we will be going through a very amazing topic, which is embeddings. But first, I want to ask to the audience from 0 to 10 in the chat, where 0 is I have no idea what's that, and 10 is I am an expert in that. Please write down from 0 to 10 how much you know about embeddings. Okay, we have Shiva with 0. I encourage everyone. Oh, Laura has 4 to 5. That's good. She's going to help me a lot. Mohammed 0, Barrera 5, Swati 5. Good. Wow. That's amazing. Michael has 4. Oh my God. What if I am a 4 or 5 as well? Okay, we're going to have the zeros, right? Very good. So 0, Molakif. So we have a combined group. Okay, yeah, sorry, what is this? We are entering a number from 0 to 10, where 0 is I have no idea what embeddings are, and 10 is I am an expert in embeddings. So Ahmedullah, what is your number from 0 to 10? Okay, why? It's 5. Very good. Okay, so it seems we have a group that is balanced. Some of us have no idea. Some of us have some idea, which is great. Again, I will not say that I am a master in embeddings, but I have done, some projects in embeddings, and I find embeddings probably one of the most amazing components of NLP. One of the things that I did, my first project in with embeddings was my wife is a writer. She writes novels, and she writes novels for adults, but mainly for kids. She does like tales and books for kids in Spanish and English, so that kids can learn to read both in Spanish and English. So my first project was with one of her books, because I said it would be great to speak with the book. It would be great if I could ask questions to the book about the book, and the book would answer me. So I embarked in this task, and I created my first embedding project, and I was amazed. We took her book, we put it in an embedding database, and from that point on, we can basically ask the book anything about it. My second project, and it's an ongoing project, is with a very recognized movie director of Hollywood. Actually, they recently released in Netflix the latest movie by Jennifer Aniston and Adam Sandler. And I'm working with them to use embeddings in the whole process of creating scripts and movies. That's very interesting. And my third project, which you can find in my GitHub, is with The Little Prince, the book The Little Prince. I think we all have read it. I wanted to do the same thing that I did with my wife's book. So I took the Little Prince and I put it in embeddings, and I can ask any questions to the book about The Little Prince, which, by the way, is one of my favorite books. I have read it, I don't know, probably 20 times. It's amazing. Okay, so embeddings. Let me start sharing my screen. And also, please feel free to ask any questions. At any moment, you can interrupt me, because I know that questions come like that, and I want to get those questions in the spot. Okay, I see a comment from Laura. Hi all, thanks for joining. When you have questions, please write them. Yeah, write them down, and I have my chat here open, so I will be able to see your questions as well. Okay, I'm going to start sharing my screen. And first, I'm going to start with some, theory with my PowerPoint. Everybody can see my screen now?
Yes.
Good. Let me arrange this a little bit. Hold on, so that I can continue looking at my chat. How do I move this? Oh man. Okay. Hopefully this works. Okay. So embeddings in machine learning. What are embeddings? Some examples. How do embeddings work? Why are they so effective? And then we're going to jump into a practical demonstration. Basically, I will start with a blank Jupyter notebook, and we will program embeddings. So let's go for it. What are embeddings? Embeddings are numbers. Embeddings are a vector of numbers. Basically, what it does is it takes a word or a sentence or an image and converts that word and sentence and image into a set of numbers, into a vector, okay? This vector is in a space, a very highly multidimensional space. So key takeaway here, embeddings are numbers that represent a word or a sentence or an image or something, okay? That is a simple concept. However, let me tell you, it took me a while to understand embeddings. I think that the first time I heard about embeddings, by the way, some history, I've been in machine learning for less than 2 years. I started in January 2022. My whole life, I've been developing software as a service, platforms. I developed the entire platform. I've been probably programming for 30 years. And I built several companies around software. And every time I build a company, I create the whole platform. And then when the platform starts to sell, I start hiring developers, and then I just become the CEO of the company. But my life is developing software. So, but only recently, it means January 2022, I decided that I had to learn machine learning. And I started with machine learning. So the concept of embeddings and the whole thing I know about machine learning is very young for me, but I am amazed. It's the best thing. I think all of we agree that this is like absolutely amazing. So when I heard the first time about embeddings, which it was probably a year ago, and I heard it from Andrew Ng, and I didn't get it. He said words are vectors. We take the sentence and convert it to vectors. So that concept is easy, but the deep concept, the deep understanding takes time to, it took me time to understand it, okay? So with embeddings, basically we have a database, let's call it a database, that is a dictionary of words, all the words in English, for instance, from the A to the Z, and for each word, there is a representation. There is a vector that represents that word, okay? And how do we get those numbers, okay? Well, someone at some point took all these words and used a lot of text and trained some machine learning models and arrived to these vectors. And we will see a little bit more about that. But basically, these vectors come from a training of a nice model that decided that the word dog is something and the word cat is something that is also an animal and similar to dog because they both are pets and things like that. We will see a little bit more about that. So embeddings are numbers. And if you have any question, remember, do it. Let's move on. By the way, one more disclaimer. I have 2 dogs. They are little toy poodles. They are girls, and they are super noisy. So if they start barking, I will try to quickly put mute so that you don't have to suffer that until I can calm them down. So I apologize for that in advance. They don't respect meetings. Okay. So word embeddings examples. The thing with word embeddings is, again, that they are, yeah, Wallace, go ahead.
Oh, sorry, it was a mistake. I just hit the button.
Okay, not a problem. So as I was saying, word embeddings come in data sets or in databases that you can use, or you can program your own data set or database of word embeddings. You can do it. But usually when you use word embeddings, you will download a pre-trained model. And the most popular ones are Word2Vec, Glove, Fast Text, and some others. Today, we are not going to use any of those. We will use one word embedding that Python has in a library. So very handy, quick to download and everything. So, but you can use any other. You can do a search in ChatGPT or in Google about word embeddings, and you will get these and others. So how can word embeddings be applied or used? Some of the most common uses are, you hear? Natural language processing, and for instance, sentiment analysis, language translation, and text summarization. All of those use word embeddings. And in image recognition tasks, you can identify objects, do facial recognition, and image comparison. For that, you also use word embeddings. For instance, one of the things that most caught my attention when learning embeddings was when I was building a face recognition system. Because for me, it was like magic. Here in the States, when you arrive to the airport, if you are, subscribed to some of the fast lane processes, you go into a machine, you stand in front of it, it reads your face, and it says, Juan, go ahead. You don't even have to present the password when you get to the States. It's amazing. So I was always like, how do they do it? How do they know this is me? Well, you know what? It's very simple with embeddings. They take my picture. When you subscribe to this program, they take my picture, 3 angles, 4 angles, whatever, and they convert my picture into an embedding. And then when I arrive to an airport from an international flight, this machine takes my picture again, in real time converts that picture into an embedding, and searches in a database for the most similar picture. And they find my embedding in the database. So they have the one that they just, the picture they just took and converted into embedding, and they have my embedding in the database, and they say, oh, this is Juan. And they look at me in the database and say, okay, yeah, Juan is a nice person. You can come in. You don't have to present your password. You can come in. It is as simple as that. A face recognition system is just saving a database the faces of everybody in an embedding, and then when the person is going to gain access, take a picture, convert to embedding, and search in the database for that face, and that's it. You know that, oh, this is Laura, this is Shiva, this is Swati, this is Juan. So that's how it is. Simple, very simple. Any questions so far? Okay, I want to gauge the audience, and I want to ask if this is amazing or not. Write amazing if you think this is amazing. Write in the chat if this is amazing. It is amazing. Yeah, I know it is amazing. Okay, let's move on. So, as I was saying, embeddings work with something that is called similarity. And there is one famous or the most used algorithm for searching similarity in embeddings is called the cosine similarity. Basically, what as I was saying, it takes 2 embeddings and compares them one to the other, and they look for the angle, and for that they use the dot product. So for instance, if we have 2 embeddings like the 2 arrows I have here, one for dog, one for puppy, the dot product of these 2 vectors will be a positive number, and the closer they are, the angle, the smaller the angle it is. So the closer the concepts are. So dog and puppy are in this space very close to each other. Okay. But if I, for instance, want to compare the embedding of dog with sky, I have the 2 embeddings and I do a dot product. If the model is properly trained, this dot product should give us something very close to 0. usually it's going to be an orthogonal relationship between the two vectors, which means there is no relationship between dog and sky. But if we take, for instance, a sentiment algorithm, when you are qualifying or reviewing movies, bad movie, good movie, I loved it, I hated it, then you are using words like good and bad that when they are converted into vectors with the embedding that you pick, they should look like opposite. Okay? So in this case, the dot product will be less than 0. Good is pointing in one direction, bad is pointing in the other direction. And that's how, when you use embeddings to, for instance, ask my wife's book a question, what I write is a sentence. I take this sentence and I convert it into embeddings, and I go through the entire database of embeddings of the book, and I find the closest matches for that embedding, and I extract it, I process it into a nice sentence, and I answer, okay? Who are the main characters in the book? I convert that question into an embedding, I go through the database of embeddings of the book, and I extract those that contain characters, and I answer the question. That's how it works. Any questions so far?
Nope.
Perfect. Okay. Why are embedding effective? Because they capture meaningful relationships between objects and concepts and semantics. I mean, this is a magic thing, like one of the best findings. When you train a machine learning model to find or to define a database of embeddings, and you do it with a lot of text, at the end, you end up with a list of words, and each word with an embedding. And the magic is that in that number, in that vector, you will have a meaning of the word, the semantic of the word in the context. If you are working with sentences, you have the meaning of that sentence in the whole context. So it is really amazing what you can do with these embeddings, and that's why they become so effective. That's one of the magics of machine learning. And talking about magic, I said that I joined ML back in January 2022 because I couldn't understand how can they do this magic. So I was able to learn the math beyond or behind machine learning. I know exactly how to build a model from scratch. I don't even need libraries to do it. I don't need TensorFlow. I can do it very, very, very from scratch. So I learned it from scratch. And you know what? It's still magic. It's still magic. That's amazing. Okay, so now we are going to jump into a practical demonstration. I'm going to close this screen, and while I open my Visual Studio, I want to ask if any of you have any question.
No.
Perfect. Let me arrange this. Just a second. Okay, I'm going to open my Visual Studio. Let me know if you see my Visual Studio now. Visual Studio Code. Yeah,
Yes.
Mohammed, it searches for meaning, not just characters. That is correct. It's since it works in the context of the rest of the words, then it is the machine learning algorithm or model is able to get the semantics of it, which is at the end of the day the meaning. When you talk about the semantics, you're talking about meaning of the word in a context. So when you do that, you are really looking for meanings there. Okay. To get us started, I have prepared a data set. And let me show you my data set. I used one of the files from our project, to make it contextual to what we're doing. And let me show you my data set so we all know what I am working with. So I think that I was able to get one of the EDECA files. I think this is one of the EDECA files. Basically, it is taken as is. If you download it from, it is EDECA or Rewa, I don't remember. But basically, I got it with, and this is before we changed the standard names. I have prod ID, prod name, prod brand, the link, the image, the product category, the price, the product description, and let me see if I have anything else. No, and that's it. I think I deleted the rest of the columns for this exercise. So this is the database that I have used for our demo, okay? So we are going to develop this demo in the context of the project, okay? And let me get this down and go back to my Visual Code. By the way, who uses Visual Code to program machine learning here? Or am I the only one using Visual Code? No, I'm sure that many of you use Visual Code. Okay,
You mean
can you see
Code?
VS Code? Yeah,
Yeah, I'm using it.
yeah, Visual Studio
Yeah,
Code.
here too.
Very, very nice. Perfect. So let's get started. I have opened a blank Jupyter notebook, and I'm going to start by, uploading our data set. Let me run this here. I am going to import pandas. As you know, when you want to import a library, you go to the terminal and you enter pip install pandas or whatever, right? We all know that, but just in case. And then I have imported panda, and I'm going to enter my path, and I called it dataset.csv. And what I'm going to do is I'm going to read the CSV file. I like to comment a little bit into a data frame of Panda. So to do that, I just go like df equals pd.read. CSV is going to be a CSV. I pick CSV as my library or my method in the library, and I enter the name of my file, and I shift enter, and I have loaded my data set into my data frame. And let's see the columns to make sure that we're talking about the one that I showed you. So we have prod ID, prod name, prod brand, link, image, category, price, description. Perfect. That's what we have read before. Now, what we are going to do is we're going to see a little bit about the column that we will be using for this project, which is basically prod description. We have more data here. We have brand, we have name. We could concatenate all that into a single column and use the whole thing. But for this example, I'm going to take only prod description. So let's calculate the length of the distribution of the strings in this column. For that, we can go like length distribution, let's call it like that, equals, I'm going to say df, and the column is called prod description. And we're going to go string length, and then we're going to go value counts and sort it by the size. I want to see it in ascending, I want to see it in descending. So we will go like false. And now here we have in length distribution, the distribution, and let's print it. Length distribution, and let's run this, what happens. So basically what this tells me is that I have one sentence with 2,700 characters. It goes all the 25. I have two sentences with 62. I have three sentences with just two. So that's kind of the distribution. I could see this in a graphic, but I'm not going to go there. You can do it later if you want. But I wanted to see kind of how big are these descriptions. So it seems we have three that have only two characters, but we have juicy meat here. We have many sentences that are with 1,000, 2,000 characters. So we have good descriptions. Okay, let's see what else we can do here. What I will do here is let's go with a length of this. Somebody raise the hand now. Length.
Yeah. The thing is, can you show me the values once, please? Because it would be like one value at least. What is the value which we are getting? In that sense, it would be
You're sent. Yeah. You're getting basically you're getting the text that I showed you before. That's
okay.
what we're getting yet. No, we're
Okay.
not getting.
Let me assume it is the or like the complete sentence or a single word.
No, it's the complete sentence.
Okay, makes sense. Thank you.
That's what we're getting there. Now we are not getting yet into the magic of the embedding. We're kind of exploring a little bit our data here. Okay, let me write this down. Length. And of course, I have this little bit. It's not like I am doing this from memory, you know. So let me write down some code here. I should probably copy paste here because of course I am prepared with my code because I don't want to mess with you. In the meantime, if you have any questions, go ahead and ask. This is a good time to ask questions. There you go. Oh boy. Let's see where we have it. We have a length, string length. We have bins, range. What I'm going is, here we have how many sentences, how many characters we have, how many sentences we have with this amount of characters, right? I have one, but I want to kind of group it to see, in a more aggregated way, what we have here. We have group length, panda, we have the length. We have the length. So you can see that this is real life coding, right? Value counts. Okay. Perfect. Group length. We have 23 groups ordered by groups of 100. Okay. So now we're going to start loading the necessary libraries to start doing our embeddings, okay? Laura says, Mohammed, perhaps you try changing the layout of me. I suggest increasing the font size. Yeah, hold on. That is important. Let me see if I can increase my font size. How about that? Mohammed, can you see better? Perfect. Okay, so we're going to use a library called sentence transformers, and we're going to import sentence transformer. So you have to import this library with pip. Remember, you go pip install sentence transformers. You do it in your terminal. And when we and this is the embedding library that we will be using for this tutorial. And I will also use sklearn that we all know, metrics dot pairwise, and this is going to help us look similarities. And we are going to use the cosine similarity to find vectors that are similar one to each other. Let's run this, and yeah, they work. So remember, these two libraries are going to be used for this. The first one is going to be used to convert the embeddings, and the second one is going to find similarities, okay? And at this point, we're going to create the model using the, or load the pre-trained model from the transformer into a local variable so that we can use it. So I'm going to go like sentence transformer, and I will use, and this is probably one of the key parts here, we are going to use paraphrase, write this properly, paraphrase the Steel Roberta base version 1. So as I shared before, there are many libraries that contain embeddings, and this is one of them, and this is the one that we're going to use. You can find others, but for the sake of this exercise, we will use this one here. It's small, it's quick, it's good enough. You can go with other more robust things, but let's use this one. Okay, so now that we have a model that contains a, let's call it a dictionary of words versus their vectors, we're going to start having some fun. And we're going to use a few more libraries. We're going to import NumPy. And we are going to go like descriptions equals, we're going to get from our data frame the product descriptions, prod description, load it into a list, and we are going to create a file called embeddings file, which is called, it's going to be called description, and you can give it any name, description embeddings.mp. Okay. Questions here? Good. Now let's see if this file, I usually try to verify if a file exists or not, but let's jump straight to create a model or create a file that contains the embeddings of the descriptions. That's our goal, okay? So we're going to go like this. Descriptions, embeddings equals model.encode, and we are going to pass it the list of descriptions. Okay? So check out what we're doing here. We're getting all the descriptions of the file, the column product description into a list, and we are going to create the embeddings of each description, and we're going to save that into a file. To convert the sentences of the description into embeddings, we will use the model that we instantiated here. We're going to call the method encode, and we will pass the parameter descriptions, which are the list of sentences that we have. Okay. Let me do something for Shiva. Now that we have, let me run it first. Actually, let me do something here. Descriptions, embeddings, and I'm going to move this to another cell so that we can check this out. Let me delete this and let me print descriptions. So Shiva, these are basically, the sentences or the descriptions, okay? So now I'm going to clear everything and repeat. We're taking the descriptions and we're going to pass it to the model to encode it into embeddings. And I'm going to run this. At this point, it is traversing the entire descriptions list. And for each one, it is getting the embedding and is saving that embedding of that description into this description embeddings variable. This is going to take a couple of minutes. So in the meantime, we can, share thoughts, ask questions until this finishes. Any questions so far?
So if it's like what is the file called npy? What is the full form of it? Like what?
We will use it in a minute. Basically, this is what happens here, Shiva and team. I am converting everything into embeddings, and you will see that this takes some time. You don't want to do this every single time you run this program. And since the text is more or less static, what we're going to do is going to take what we are calculating right now, and we are going to save it into a local file. Okay, and for that, it's going to be this description embedding MPY file. We're going to save this here, and I will save it as soon as this finishes. Once this finishes, I'm going to save it, and let me write this sentence right now. What I'm going to do is going to be basically np save, and MPY is a format of the NumPy library for a file. Okay,
so basically we are saving the model, am I right?
The model, not the result of the model.
Okay,
good. We're going to save in the embeddings file, we're going to save the description embeddings. Once this finishes, I'm going to run this sentence, and that's going to save all these embeddings into this file. Okay, so let's finish. Is it clear, Shiva?
Yes, thank you.
Perfect. It should be finishing in about 1 minute. Any other question? So while this finishes, let's summarize. We opened a text file or a CSV, and we are concentrating in a column which is called the product description, which contains text. And we're loading that text into a list called descriptions. And we're using a model that we downloaded with the sentence transformer. And the one that we're using is Paraphrase Distill Roberta base version 1. And there are many. You can, if you go to Google and you explore this library, sentence transformers, you will see all the options that you have as far as embedding database. At this moment, we instantiated the model, and we passed to the model the list of sentences, and the model is encoding every single sentence into an embedding, and now we finished. 3 minutes, 21 seconds. Now I'm going to save this into my local folder, and let me see if I should share differently. Hold on. Let me share my screen, but this is going to be double. Share. Screen share. So if I look at my folder, now I have the file here. Description embeddings, MPY. What happens if we open this, right? If we open this, let's see if it loads, because it's a large one.
Is it in gibberish?
Gibberish. No. Let's see what happens. Yeah, it will take a while because it's a big file. Let me just, you can do it later, but it's going to be showing you the numbers of the embeddings. Let's ignore that for now. Okay, let's go back here, and let me share my notebook again. And now that we have the embeddings, let's start playing nicely. For instance, I want to ask my embeddings, what are the products that include banana, for instance? Okay, let's start playing with this because I already have my embedding. So it's time to ask questions. I'm going to use query embedding equals model.encode.query. Remember when I told you that on a face recognition system, they take my picture when I arrive to the airport and they convert it into encoding? That's exactly what we're doing right now. We're taking a question and we are converting it into an encoding. So now query is an embedding. This is the embedding of the query that we just entered, okay? A lot of numbers. Now, Shiva, now you can see an embedding in real life. It's just a vector. Now that we have creating this embedding, we can find similarities in our database. And for that, as I said, we're going to use the cosine similarity, which we got from the SCKit library. We're going to pass the query that we just encoded, the query embedding, and we are going to pass the entire database of embeddings that we just got. And we're going to run this. Oops, let's see what happened. Let's see what's the error here. Query embeddings and description embeddings, cosine similarity. Let me rerun this library here. And be there. Huh. Query embedding and description embeddings are being passed to the cosine similarity. Oh, I see what the problem is. Yeah, no, my problem was here. When I created the embedding, this actually is asking for a list. I passed. Okay, so let's rerun this, and let's rerun this. And there you go. We have been able to run this. And what I'm going to do here, because it returns multiple values, I'm going to go like n, top n equal 5. So I'm going to get the top n indices of the similarities that we just got. And let me get so as you can see, this is real life coding. So what I'm doing here is I'm getting the top 5 results ordered in descending order, meaning the most similar ones, and I got the indices of those top 5 into this object here. Remember, we have a list of descriptions, and now we have a list of embeddings that are one-to-one with my list of descriptions. What I just did was, from this question, get me out of this list of embeddings the most similars. So it got me a subset of the whole embeddings list. And this subset is ordered from less to most similar. And I want to tell the system, give me the top n most similar to my question. So I take the ones from the bottom up, the top n. So I'm getting the 5 most similar answers to my question. I don't need to take everything, just 5 or 10. Or, for instance, when we do our project, we can define that as a hyperparameter, and we can probably ask the user, okay, how many similar products you want to get? 10, 5, 2? And the user can search, define that, and we will pick the most similar ones depending on the user, whatever he wants, right? Okay, and now what we're going to take is convert these indices, not using the embedding, but using the actual database of descriptions, to take the indices of this description and see what products the system is suggesting. So for index, in the top n indices, please print the product that we got from this list. Okay, so for that, I'm going to take from the data frame, locate the index, okay, the index. I'm going to get the product ID, or we can get the prod name. I think it was prod name, right? And we can have the description going to be descriptions index. Let's see if this is properly written. And here we are. He asked the system to bring me products that contain banana. And we have the 3 bears porridge, this one here, and the description, the unpackaged organic banana slices, 250 grams, the Casali chocolate bananas, 300 grams, and the description, and so on and so on. So we were able to take this database and then convert it into embeddings, and now we can ask questions to it. What I'm going to do now is I'm going to jump to another file that I had prepared, where I am taking all of this. Let me jump here, app embeddings, training. Can you see my screen? The new file? Yes, perfect. So in this file, basically what I did was I took all the code of this notebook and put it into Python, into a Python file. Why did I do it? Because I want to see this in a different light. I want to use Streamlit here, and I organized a little bit the code. All the libraries are up here: Pandas, NumPy, the sentence transformer, the sklearn, the OS, and now Streamlit, which Wallace is going to be showing us next week how to use Streamlit in a nice webinar. The rest is the same. We're going to take this dataset CSV file. We're going to instantiate the model, get descriptions, calculate the embeddings. Here I added something. If the embedding file already exists, don't calculate it. If it exists, just load it. Then we have Streamlit title. I'm going to call it product search. I'm going to enter an input for the query, and I'm going to start in a loop using Streamlit to ask questions and produce the results. So let's see this in action. Hold on. Let me jump. Dropbox, desk, machine learning, Olena. Olena, this is CD in CD training embeddings. Yep, here I am. So I'm going to take this command and paste it here, and I'm going to run this. I think that is not showing. Let me share my screen. Okay. Hopefully this works. Okay, it's running. It's running. Okay, product search. Enter your query. So from the audience, who wants to ask for a question here? What product do you want? I want some milk, for instance, right? Let's see what happens. Top matching products. We have the icon of the milk, category, coffee tea, product brand, product name, price, product package. If I click link, it takes me to the actual page of the product. Nice. And I say, oh, Nesquik. And I have, for instance, another product here. So as you can see, we can get a nice thing out of this. I want some coffee. So it has coffee, and it has, so this was done with Streamlit. As you can see, it's very nice. And we can allow the user to enter any question here. For instance, Apple. If I enter Apple, what it brings. So it matches something. So we have to fine tune it a little bit because it's bringing products with Apple, but maybe I want to buy just apples and it's not showing me that. I don't know if the library has it, if the data, the CVS field has it file, but at least we have a way to match sentences with products here. So I think it's very neat. Okay, so questions.
So I
Swati.
need coffee.
Hello. Yeah.
Yeah.
Yes, Yuan. So I just wanted to know, can I search for a particular field only instead of getting all the information related to that product?
You can search. I mean, the search itself is going to be based on the context that you give the program. In this case,
Yeah.
the context I gave it was the description of the product. But if I want to search by a particular field from the different columns of the CSV, we would have either to include those into the description so that they are indexed or embedded, or we can use a different method, like, for instance, combine a relational search with embeddings. For instance, I could tell the system, show me a combo box or a selection box where I can pick the categories. And I, for instance, have milk and bread and vegetables and fruits. So I can pick fruit. And when I pick fruits, then we can narrow down the embeddings database to fruits only. And then please show me the apples that you have. And in this moment, we can show to the user only or search in the database only things that are in the fruits category and show the results from that. So those are things that we will have to define as a group, how we want the user interface to look like, and how we want the user to search for products. And then we can do it like that, using filters like that.
Okay. Yeah, got it. Thank you.
Absolutely. Michael, question? Michael has a question? Okay, Shiva?
Yes. So the thing is, for me, how did it get to know if it's I want? We are not using I want and all those in the description, right? Is it just getting the apple or matching just apple or mango or banana and retrieving us the data, or else if no, then how is it learning that I want, and it is considering that as a sentence? And yeah, I hope you got that.
Yeah, I get that. And I agree with you. And this is a little bit what I call magic. Basically, you saw that if I enter, I want apples, or I need apples, or look for apples, these three sentences somehow, when you convert them into a vector, these three sentences are kind of similar. When the model that we used was trained, it found correlations between these words. So when they put them together in a sentence, like we did, the resulting vectors come up with a certain direction. And when it goes to the descriptions, it will probably use part of the embedding, like apples, and like if it seems that apples is in a context of desired result, because I want, I need, I look for, right? So the algorithm will look for embeddings that contain apple as a desirable result. That's my best way of explaining this. I don't know any other way to explain it, but basically the vectors that the system found are somehow correlated, are close on the dot product.
Okay. So the
right?
angles are close.
Yeah, and it's crazy, because, for instance, when I ask the book, The Little Prince or my wife's novel, a question, give me the characters of the book. Look how I am not giving any name, but it brings the names. You see, it's magic. It's crazy. And at the end of the day, behind it is just mathematics of vectors that are close to each other, thanks to a model that trained them in that way, right?
So I have an other question. So can you show me like what are the differences which we if we ask I want an apple, and on the other hand apple is are the results same?
Yeah, which I did that example just now, and the results were not exactly the same but similar.
Okay.
And I invite you to play with it.
I would love to.
Yeah, because I think I will share the repository, and we can download it, and we will upload this notebook to Notion so that it is an asset of the project. So you can download it and play with it as much as you want.
Thank you.
Laura.
Thank you, Juan. Yeah, my question was related to what Punes just said. I was wondering, I mean, thinking about our user interface, how we need to instruct or guide our user into how to use this interface. So whether it would be actually, does the person need to actually write a full sentence or just indicate what type of product they need?
Right.
I mean, meaning if they need a verb or just say, you know what I mean?
No. And the magic of NLP's embeddings is that when we use a properly trained model, the user can be very creative. I mean, we don't have to instruct them. And one of the characteristics of a good UI is that it should be intuitive. If we have to give instructions, then something's funny, you know? So we should not give instructions. We should allow the user to just enter the search as he wants or as they want to do it. So they can enter Apple, or I want Apple, or I need Apple and this, or I need to create or to cook an apple strudel or strudel, and it should help us. We will see how it works, and we have to play with different libraries to maybe find one that is robust enough to help us produce better answers.
And in this sense, what you were saying before, doing a relational database that we can actually ask, where can I get the best price for X product, correct?
Yeah, I think that the project, to be more robust, should be based not only on embeddings or a model, but also a relational database that allow us to create additional filters that the model not necessarily will provide as specifically as we want. So a combination of technologies will lead us to a more appropriate or a better result.
Mm-hmm. I understand. Thank you.
Michael, you had a question?
Can you hear me?
Yeah.
Sorry. Okay. I mean, you kind of answered it. I think I had kind of the same question as Shiva, but I have another question. So I know you said to Swati that we can kind of narrow it down by selecting a category beforehand, but you also mentioned we can tweak the model to, if we search Apple and then Apple doesn't actually show up, we can tweak it so that things like that do better. How would you go about actually tweaking the sentence transformer or the cosine similarity?
Right. So no, I don't. I didn't say exactly that, but I will answer your question. I would not go into tweaking the model because that would be basically retraining a model for our purpose, and I think that's out of the scope of the project. However, if we wanted to do that, the way to do it is basically we could build a data set, a training data set with all the different combinations that we want. And we could build a model to create embeddings, which is not a difficult thing, but it will be time-consuming and power-consuming. We will need probably something powerful to train it quickly. And we could train a model of embeddings that is built exactly to our needs. We could do that. It's not what I recommend because that's a different project, and that will, but if we want, we can do it in parallel. I mean, that would be an interesting exercise. But we should use a robust embeddings database. But what I was telling Swati was that the user can enter anything. The user can change the query they enter in natural language, and we can use additional filters to narrow down the scope of the search and produce better results. That's really what I was saying. Not that we will tweak the model to respond differently. That would require not a total training. We could do probably a fine-tuning of a model, but if we could think about it if we want to do something like that. Any other question? Okay, it's 9:01, so I think we were in the nick of time. If there are no more questions, I hope that's helped. I want to ask for those that were in 0 at the beginning,
4,
meaning
5.
Meaning 0, I don't know anything. What is your new score from 0 to 10? Have you learned a little bit about it?
At least 4 for me.
Perfect. I'm glad. Anyone else with who started with a 0 has learned a little bit more about embeddings? Okay, another question. Any recommendation for a future training to make it better? What should I do better next time so that I can teach you better? Because I'm planning for another webinar, if Laura allows. I want to, and maybe we can join hands with somebody else. I wanted to do this training with Cindy, but she was not available. And Michael, I think we finally couldn't fine-tune our schedules to do it. But I want to do another training if possible on a recommender system using the Instacart library to see one that is on collaborative. Anyways, if there is something I can do better, just let me know and I will improve. But I loved sharing this with you all. I will be uploading the code now, the PowerPoint, the data set, and the code so that all of you can play with it. Also, I will share my GitHub of the Little Prince if you want to download it and play with it and ask questions to the Little Prince. That's an amazing experience. And in the meantime, I appreciate everybody's time and see you around.
Thank you so much, Juan. It was really great. I really learned a lot from your explanations, some of the things I didn't know. So for me, it was very, very helpful. And I'm super excited to see all the possibilities that we have for our project with this technique. We can definitely take into consideration, and hopefully we'll be able to brainstorm together what we want to do with this. Wallace, please.
So, Juan, thank you for your explanation. It was quite good for me, quite clear. And
yes, I can
would
hear you.
say if you are not a teacher or a professor, you can try. Right? You have the talent.
Oh, thank you. Thank you very much.
Congratulations.
No, you know where I think I learned that? When I was like 18, I was a clown. I used to animate parties for children, and that allowed me to learn how to speak in public. To kids, imagine that. Making laugh.
Nice.
Well,
Yeah.
they are very hard, como se dice, public, so you... Svati?
Yeah, and thanks. Thanks for the webinar again. It will help us to generate attributes, definitely. So actually, I don't have any subtask leader for generate attributes right now. So can we have a combined meeting for all members who are interested in subtask generate attribute with you? And can we discuss all this procedure and things tomorrow? Maybe possible if.
Yes, I have time. So Laura, Laura will tell us when, where, and I will be more than happy to get together with all of you.
Thank you, Juan. We have our group meeting on Sunday scheduled for the same time as today's meeting. where we can discuss where we are with the full project, but we definitely can open other times for what you are proposing, Swati. Maybe we can define it a little bit more on the chat and see when we can do that. And Juan, please do continue to share. I love to have more webinars from you and from other people from our team, members. It's really helpful for us to just really appreciate and like take all the opportunities possible from this experience to learn from each other. So I really encourage you, everybody, to please come forward, reach out to me, and I will definitely help you out to organize this and then share it to the world. So don't be shy.
Perfect. Thank you.
So thank you so much, Juan, again. And if nobody has any more questions, I hope to see you, everybody. See you all on Sunday.
Perfect. Thank you very much. Bye-bye, everybody.
Okay, bye-bye.
Bye. Thank you.
Bye-bye. Thank you.